Hello, Mr. Wilford here, and I just want to go through week 3 with you, and we are going to wrap up chapter 1. We're looking at sections 7, 8, and 9 for chapter 1 here, and then we'll finish up the week with a test. So hopefully you are moving along okay and you're in the course, and we're already on week 3 here. So um, again, I just want to kind of go through and talk a little bit about each of the sections and what you are going to be looking at here. Hopefully that will help you out. In section 7, we're going to be talking about function notation, and function notation is really just symbolism, and this is an extension from what we talked about last week when we were talking about functions. Um, we are now going to take a look at function notation, which is basically symbolism for a function, which is really just an equation. A lot of times people will get wrapped up in function notation and they're not sure what it is and what it looks like. You should always think of it as just an equation. Basically, the reason that mathematicians use function notation is to name an equation so that we don't have to talk about the whole equation. We don't have to list and read the whole equation. We can basically just talk about a function. And a function is a name of an equation. And it's listed as a letter. Typically, you're going to see the letter F. The way that this is read is f of x. Really what that means is y equals 5x plus 3. The way that we write it is f of x equals 5x plus 3. And this is the function notation. Now you can use different letters instead of f. You'll maybe see like g or h of x, g of x, f of x. But again, keep in mind that if that bothers you, just put a y there. So like down here, y equals 5x plus 3. When we talk about function notation, what we're doing is we're really going to plug a number in for x. That's part of our domain. And we're going to get out, after we plug that number in for x and figure this out on the right, we're going to simplify that and get a number. That number that we get out is what is going to be the output value. That's going to be the range, or it's part of the range, and it's going to be our y value. Okay, so every number that you plug in for x goes here. That's part of your domain. Every number that you get out after you work the function is part of your range. It's your y values. All right, so you're going to have some problems that are going to look like this, and they're going to ask you to evaluate f of, and then they're going to give you different x values. As you can see here in this example, we're plugging 0 into the function for x, calculating it out, and the number that we get out is what it equals. It's what the y value is equal to. So for each of these, you can see how we get a number out. So basically, for this problem, for part A here, the x values are here, and the y values would be what we simplify. You can talk about those as points on a grid, on a coordinate system. Now, if you're given a graph and you have to find these values, for example, f of 0, we would go on the x-axis at 0, and we would go until we hit the graph. And so y at that value is 4, so we get out 4. F of negative 2, we go to the negative 2 on the x, we go up until we hit the graph, and we read the graph on the y-axis, and that is 2. Okay, so it's just getting used to using the function notation. What it really means, it's basically just an equation again. Continuing with that thought, we have the dependent variable and the independent variable. When we have an equation, a function, the independent variable is the one that is the x value. It's the one that we plug in for x, or in this case, t. That is the independent variable. The dependent variable, because it depends on what we plug in, the dependent variable is the y. It's what we get out. All right, so we have independent variable the x and the dependent variable the y. And again, you're going to see you have a couple more examples here where you're just graphing the function. These would be the x's, these would be the y's. Basically, you're just plotting points. Same thing here, except they give you the function. They're giving us a table of values. Here are the values for a. Really, this would be the x. What we get out over here would be the y values, and you can plot these points on a graph and connect the dots. So there'll be some examples here where you're going to have to graph each of the functions. And we're going to use functions throughout, really throughout this course. So it's a good idea to make sure that you understand that a function is really just an equation. Here's another example showing you some things. Real world problem. And then we have our problems that we're going to be doing for this section. So make sure again that you look for the online book assignment, and it will tell you what page and problems to do here. All right, that's basically section 7. Now let's go to section 8. Section 8 is all about exploring transformations. Now, in geometry, you talk about transformations, and basically there you're talking about picking up a geometric figure and moving it left and right, up and down. You might be stretching it one way or another, doing different things to it. Same thing is here. Transformation is a change of position, size, or shape of a figure. A translation is really where we're going, it's a certain kind of transformation, and we're moving that figure left and right, up and down. Okay. The idea here is that we want to watch the x and y values, and what we do to them is going to obviously change where the points are. So here in this example, you're given a point and you want to move it 4 units to the left. Well, what does that do to the x or y value? In this case, it's just going to change the x value to a -2. In this example here, we can move it 2 units to the right and 3 units up. What does that do to the x and y value? So you're going to be doing some transformations or translations in this part, where you're just moving points. Now, they're going to give you these horizontal translation and vertical translations and what they do to the x's and y's. I'm not sure exactly if you need to copy all of this down, but it's a good idea to understand what happens when you move it left and right, the point, what's changing in the x, and if you move it up and down, what's changing in the y. So make sure that you take note of that. Then we have what's called a reflection. A reflection basically is flipping the figure across a line. It's across the x-axis or the y-axis typically, but it can be other places. And we have a reflection across the y and a reflection across the x. Again, notice what happens to the x's and y's in each case. If you reflect it across the y, what are you doing? You're changing the sign in the x value. If you're reflecting across the x-axis, then you are changing the sign in the y. Okay, so make sure that you kind of take note of that as well. Then we're going to start putting these things together. So we have a translation, translating and reflecting a function. So they're going to give you a graph, they're going to give you a function, and you have to be able to figure out what these translations and reflections will do. What they do here is they list a bunch of points, okay, which is fine, but it's maybe a good idea to maybe kind of sketch these out on paper. This is the original function. If you move it 2 units down, what happens to some of these points? In particular, what happens to the y coordinates? If you are reflecting it across the y-axis. Now remember, the y-axis, okay, changes the sign in the x. So notice that we're changing the signs in the x's here. Okay, So watch for that again. Make sure that you take note of those things that are happening. We also can take the graph and we can stretch it or compress it, and you can do this horizontally or vertically. Now this is a little bit tricky. It kind of depends on what your graph looks like, so you have to be a little bit careful what you're doing here. But basically you're multiplying a number this time to either the x-coordinate or the y-coordinate, and then it depends. If you're multiplying it by a number greater than 1 in this example, you're going to stretch it horizontally. If you multiply it by a number that's between 0 and 1, you're going to compress it. You're going to squeeze it together horizontally. And then this is vertically, and this is the same thing except it's to the y-axis. So again, if you kind of take a look at these examples, what's happening and what are they doing to each of these as you go through it. Another example here, a real world problem, and then we have our problems here that we're doing. So transformations, it's a little bit tricky. Just make sure you take your time to look at some of the examples. In the last section, we're talking about parent functions. And the reason we talk about parent functions is because we're really going to talk about all of these kinds of functions throughout this course. So it's a good idea to understand a parent function really is the most basic kind of function that you can have. We have a constant function, a linear function, quadratic, cubic, and square root. And we'll actually talk about some other ones, but these are the most basic kinds of functions that we talk about. And the graphing calculator actually will help you a lot with some of this stuff. So if you have a graphing calculator, that's great. Otherwise, you can look online for a graphing calculator, and there's usually one there. But get used to using a graphing calculator because that's going to help you quite a bit. And you can put in a parent function and a new function, and you can see the change that happens on a graphing calculator. And they go through a couple of different examples here. Again, using a graphing calculator, you might plug in y equals x squared. That's the parent function for a quadratic. And then if you plug this into a graphing calculator, where does it go? What happens to the graph? Well, it shifts it over to the right. So we're kind of comparing the most basic function to a new function, and how is it getting shifted around up and down, left and right, or how is it getting compressed or stretched. So go through some of these examples, use a graphing calculator, and that will for sure help you out if you have a graphing calculator that you can use. Again, some of the problems here that you're going to be working on. Just a reminder again, I would make sure that you use some of the resources that are here. They're very interactive, they're very helpful to kind of check your work and see how you're doing. And as always, if you have any questions, please let me know, and good luck this week and good luck on the test. Thank you.